So let's go ahead and look at your review guide here. I'll try and solve each problem as quickly as I can, as I'll also giving you insight into what they're asking about. First of all, is this function? So they're telling us it is a function. The question is, though, is it a polynomial? To determine if something's a polynomial, you need to look at your exponents. And as long as they're whole numbers, that means only 0, 1, 2, 3, etc. And there's no x's in denominator, then it will graph and make a nice smooth graph. I'm in Nator. And it will be a polynomial. So yes, this is. All our exponents are nice whole integers. By the way, the reason you can't have x's in the denominator is like 1 over x is the same as x to the negative 1 exponent. So x's in denominators mean exponents that are negative, and those are not whole numbers, and so they are not polynomials. Now let's put it in standard form. In standard form, what we're going to do is make sure the highest degree, 7 in this case, degrees are exponents, is first. So the x to the 7th term, negative 15x to the 7th, has to be first. Next highest is the negative x cubed, and third highest is the x squared term. So here's your 7th degree term, your cubic term, and your quadratic. Remember, x squareds are quadratic. So there it is in standard form. Check that one off. It's degree. Well, each one of these has degree, degree 7, degree 3, degree 2. The degree of the whole thing is the highest one, so degree 7. Let's put that. Degree equals 7. It's type, so this would be a 7th degree, and it's got 3 terms in it, 1, 2, 3, so trinomial. So we've stated degree, it's type, 7th degree trinomial, lead coefficient. What's the number in front? Negative 15. It's your lead coefficient. Lead meaning front. Co meaning co with the variable. What number goes with that variable? X to the 7th. Negative 15 does. All right, here we go. A multiplication problem. So there's number 1. Let's look at number 2 now. Slide this thing up a little bit. Let's take all those answers with it if we can. So here comes problem number 2. I've got it blown up here nice and big for us. So it's a multiplication problem. When you multiply 3 things together, the way you do it, just like if we were multiplying 2 times 3 times 4, you multiply a pair of them together, and then you take it times the third one. It doesn't matter which pair you start with. In this case, I started with 3 times 4. In this problem, I think I'm going to start with the x minus 2 times x plus 3. And then whatever that answer is, I'll take it times the 2x minus 1 at the end. So let's just focus on this right here. These are binomials, and we have to get good at these. You distribute the x. Then you have to distribute the negative 2. Then you look for any like terms. We do have some right there. So there's our first multiplication, and then we just have to take that answer, just like we did with the 12 down here, times the third factor. In this case, 2x minus 1. So here we go. I'm going to distribute that. I get 2x cubed. Remember, we add exponents when we multiply here. X to the first times x squared, x cubed. I'd take 2x times x here. It's 2x squared. Smooth things over just a little bit and shrink them down if we can. Shoot. Quite sure why it always does that. Let's group all of that together. Alright, so I've distributed my 2x and got 2x cubed, distributed 2x to x and got 2x squared. 2x to negative 6 is negative 12x. And then I'm going to distribute the negative 1. This is negative 1x squared, and I'm going to line him up underneath my other x squared term. This is negative 1x, so I'll line up that negative 1x under my x term, and this is plus 6, so I'll tack him onto the end. There we go. I just have to add up these like terms. So I've got a 2x cubed out front. My x squareds here add up to an x squared, 1x squared, and this is negative 13x plus 6. And so there's my complete factorization. Let's erase this right here. All right. And that's our complete answer for that one. I'm going to do a little grouping here, I hope. Hopefully we got all of it. Let's move on to the next one. X minus 2 cubed means x minus 2 times x minus 2 times x minus 2. And so this is just like the one above it where we had 3 binomials multiplied together. So let's go ahead and carry out that multiplication. Now I'll do this pair first. Here's what I get. Now I'm going to kind of do this a little bit in my head. There's my x squared. And I know these last two terms always give me my last term. Okay, the only ones you really have to always check is this product, that's negative 2x. This product, which is negative 2x, and negative 2x, and negative 2x is negative 4x in the middle. So there I've taken x minus 2 times x minus 2. Now I'd have to distribute my x and distribute my negative 2, and I'll be done. So when I distribute x, all it does is add one more x to each term. And when I distribute negative 2, it just doubles every term. And then I add them up to get my final result. X cubed minus 6x squared plus 4x's plus 8. So there's the product of x minus 2 times x minus 2 times x minus 2. All right, next problem. Let's see what happens here if we group it all. And we'll slide it up. There we go. Problem 3 here is just an addition problem. In fact, the parentheses don't mean anything here. All we're doing is taking a bunch of terms and adding on a bunch of more terms. And when we have that situation, we add like terms. So how many x to the fourth do we have? 3. How many x cubes? That's the only 3x cubes right there. Let's look for x squareds now. Is there only one x squared in that? Yep, looks like it. Negative x squared. Oh, no. Yeah, there is. Yep. Then we got the x terms. That's minus 3x. And then lastly, we have this 6 and this 9, so that's plus 15. There we go. That's all we can do with that. Like terms can only be added if they're like terms. This is the same problem almost. So, you'll notice here we got a minus sign right there. Let's kind of highlight him. So all we're going to do is distribute this, and when we distribute it, it becomes a positive 8x. Okay, and so as we distribute, we just write down what we have. Minus 5, this is going to become positive 8x squared. Then it'll become negative 4x. And then minus 3. And then we just look for our like terms. So I'm going to highlight some of those things for us. Let's see here. There's an x cubed term. He's the only one of those. This is an x squared and an x squared, so those get combined together. See, this is our only one with an x solely next to it, not an x squared or anything. And then these are constants. So we just have to collect those things. So I've got a 4x cubed. I got this green stuff here. That's negative 4x squared. I got this blue stuff, negative 4x. And my pink stuff, negative 8. And so there's our simplest form for it. Let's take a look at question 6. Oops, I gotta group all this stuff. I always forget that. See if I can get it so it fits in there again. Let's just hit undo, and we'll group it. All right, that takes us to problem 6 here. Problem 6, let's look what it says to do. It says, use synthetic division to find or to evaluate this function when x is negative 3. So they want to evaluate this function. They want you to find the f of negative 3. And so we could substitute that negative 3 straight into the equation and figure it out, but they said use synthetic. All right. So here, this is the remainder theorem when they tell us to do that. And what it says is that if you divide a polynomial by a factor, and I'm going to divide it by x plus 3 in this case, if I do this, then my remainder, will be the f of negative 3. It's always the 0 of what that would be. So the 0 of x plus 3, the 0 means what is x if you equal it to 0? It's negative 3. And so the remainder theorem says if I divide by x plus 3, my remainder will be the f of negative 3. So I want to do that division. Now when I do this division right here, I'm not going to do it with long division. I'm going to do it with synthetic division, which means put the 0 of whatever you're dividing by in the box. So you actually put that negative 3 in the box, do your synthetic division, and the remainder will be the f of negative 3. Oops, drew my line a little too close there. So I bring this down, negative 2, multiply, add, multiply, add, multiply, add. There we go, 76. That's the f of negative 3. Had I done, had this in here been a negative 2, then I would have had a remainder that would have told me the f of negative 2. If I put a 6 in there, it'd be the f of 6. Whatever number you put in there, the remainder tells you the value of the function at that number. All right, long division problem. Here we go. These are the ones that concern the other class the most, or other classes. So let's go ahead and do this synthetic problem, or long division problem rather. So this is our divisor right here. We're dividing by that, so that goes on the outside of our division box. And then inside goes what we're dividing into, our dividend. So it's an x cubed, an x squared, an x term. So we got all our terms. So there's the setup. Okay. Now remember, this is just like long division with numbers. If I'm doing this division problem here, I ask myself, does 3 go into 2? No. 3 times what gets me close to 26? And so I'd say 8. Then I multiply and I subtract. I do the same thing with polynomial division. What do I have to take x squared times to get x cubed? What do I have to take 3 times to get 26? The closest I could get was 8. What do I have to take x squared times to get x cubed? Not close in this case. I can get exactly x cubed just by taking it times an x. And then I multiply and subtract. So here we go. Let's carry out these multiplications. X times x squared. Line it up under my x cubes. It's 2x squared lined up under x squareds and 1x. And then we subtract. Now when you subtract this, what you want to do is distribute that negative to there and to here and to here, and then do your addition. So x cubed minus x cubed is 0. X squared minus 2x is negative 1x squared. 3 minus 1 is 2x. And then you bring down your next term. And now we just repeat. We say, hey, instead of x squared giving me x cubed when I multiply by x, I ask, what do I have to take x squared to get negative 1x squared? So I'll take it times a negative 1. Let's see here. And then I will distribute negative 1 times x squared, negative 1x squared, negative 1 times 2, negative 2x, negative 1 times 1, negative 1. It's a negative 1 up there. It's hard to see now. And then we subtract. Here we go. Distributing makes that plus, plus, plus. And we add vertically. 1 plus 1, negative 1 plus 1 is 0. 2 plus 2, 4x. Negative 4 plus 1 is negative 3. That's your remainder. I can't divide x squared into x. I can divide x squared into x cubed. I can divide x squared into x squared. I can't divide x squared into x. And so we do write our answer as our quotient, x minus 1, plus our remainder over our divisor, which was the x squared plus 2x plus 1. There would be our final answer. All right, last question on this page. We just got to factor this binomial here. So we GCF first, always GCFing. This is a difference of squares, an x squared minus a 3 squared, so it's 2x. Difference of squares, x minus 3, x plus 3. And that is the complete factorization. Here's the flip side of the review for the test. We just have to factor here. So here's our polynomial. And we're going to look for that GCF first. In this case, an 8 comes out. Notice how you get 8x cubed minus 1. 8 times 8 is 64. X cubed. 8 times negative 1 is negative 8. And then after you factor out the GCF, then you look over what's left, and you see if it's any of these other special things that we do. Okay? If it's 3 terms, we tried 2 binomials. If it's 2 terms like this, we hope it is a difference of squares, but it could be a difference of cubes like this one is. 2 cubed is 8 and 1 cubed is 1. So we have to factor that stuff in the dark red. Now, difference of cubes always factors this way. Again, this is on our formula sheet that we have. Plus AB plus B squared. So here I go now. My factorization is going to be the 8. That's this guy out front. And then my difference of cubes is going to factor this way. Okay, here's my A, 2x. And my B is a 1. So it starts with 2x minus 1. Then it says take the A value, the 2x, and square it. 2x times 2x. Take A times B, 2x times 1. And then take the B squared, so 1 squared is just 1. And there's the complete factorization of this binomial. Tough little factorization. Let's look at number 10 now. Let's see here, 2x to the 5th. It's just a factor problem, so I'm going to start with GCFing. When we say GCF, we mean variables and numbers. I keep having to reiterate that to you guys. I say, hey, what's the GCF? Everybody just gives me the 2. The GCF is 2x. It's both those. Now, I've taken that out. Notice I get 3 terms left. I'm hoping it's x to the 4th. So I'm hoping this thing will just factor as x squared and x squared. They have to multiply to 5. 1 and 5, or that's it. 1 and 5. So they both have to be negatives to give you the negative 6 in the middle. Now, always check again. That's a difference of squares. Excuse me, x minus 1, x plus 1. We've seen that a few times now. And x squared minus 5 can't be factored. It's not a difference of squares because 5 is not a perfect square. And we're done with that. Let's group all that stuff up and let's move on. Number 11, show that x plus 2 is a factor of this, then factor completely. So that means divide x plus 2 into f of x and see if your remainder is 0. Now we don't do long division for that. We do synthetic. Uh-oh, there is no x squared term, so we got to put an x in there. There we go. Let's do the synthetic. Let's hope that we get 0, and that proves that it's a factor. Look at this. Yep, remainder 0. This is x cubed plus 0x squareds plus 0x's plus a negative 27, remainder 0. And so yes, x plus 2 is a factor. Not only that, everybody, p of negative 2, we just did problems like this, is 0. Remember, we can just look at the remainder when we do this division. And so we found a solution. Negative 2 is an answer, okay? But now our job here is to factor this thing, so let's factor it. So when we go to factor it, we have got now x plus 2. That's the one we just proved was a factor. And we also have the answer to our division problem is the other factor, 1x cubed minus 27. And so now we just have to factor this difference of cubes right there. Okay, I'm going to do that rather quickly. X cubed minus 3 cubed, so my a is x. So there's my x plus 2, that's this guy. Then here I go, a minus b, x minus 3, a squared, x squared, plus ab, 3 times x, plus b squared, 9. So there's the complete factorization of that original polynomial. All right. Number 12. Number 12, list all the possible rational solutions. That's the rational root theorem. That's the P over Q stuff. It says if there are rational solutions, then P, the numerator, is factors of the 12. So here's all the factors of 12, everybody that divides evenly. Q is the factors of the lead coefficient, that 2. And the solutions are all of our P's over all of our Q's. Now this is pretty easy to do. First you do 1 over 1, 2 over 1, 3 over 1, 4 over 1. You get the idea, but that just gives you, since everybody's divided by 1, just gives you your P list. Then you have to do 1 over 2. That's a half. You have to do 2 over 2, but 2 over 2 is just 1. We already have that in our list. 3 over 2. We haven't done 3 over 2 yet. That's not in our list. 4 over 2 is 2, already in the list. 6 over 2, 3, already in the list. 12 over 2, 6, already in the list. Therefore, we are done with the list. That's all of our possible rational solutions. That brings us to problem 13 here. Find all the zeros for this thing. So, first step, get it equal to 0. Second step, I'm going to do P's and Q's. I'm going to find out what these solutions could be. Now I don't have to do my Q's here because my Q's are just factors of 1, which are 1. So P is also my P over Q list. I don't have to make a separate list for it. And so I just start testing these. Okay, now I know ahead of time which one works. The one that ended up working for me anyway was 4. But I don't know that yet. I'm just starting to try some of these, and it turns out when I used 4, I do get 0. And so that's the one that gives us our answer. Now, remember, that just tells us 4 is a solution, and once 4 is a solution here, that means that x minus 4 is the factor. And the other factor is the answer to the division problem. This is now x squared, 0x's minus 5, so we just write it like that. And so this is the factored form of this. This x squared minus 5, I can't factor any further, so now I just solve each factor. Now x squared minus 5, a little tricky, but it's a quadratic, so we can just isolate x squared, and there's our other two answers, plus root 5 and minus root 5. Remember, it's plus or minus root 5. That means those two answers. So total of 3 for our solutions. 3 solutions for that guy. And then our last one. Oh, by the way, I do want to show this. Not the only way to do this problem. So I'm going to slide this whole thing over here if I can, because I want you to see this to show you that everything we do is very consistent. So I'm going to do this same problem, x cubed minus 4x squared plus 5x plus 20, a different way. What I'm going to do is I'm going to try to solve it by grouping and see if I can factor it. So I've grouped the first two terms, and I've grouped the last two. I'm going to GCF the first pair. I'm going to GCF the second pair. That 5 can come out. Oh, shoot. I thought it was going to work. It looked like, oh, it is going to work. I wrote down my problem wrong. It's a minus 5x squared. So I'm going to pull out a negative 5 here, and watch what happens. Pull out negative 5, and I'll be left with x minus 4. But see, there's the common factor. When I do regrouping, I want to see that common factor, because then I can pull it out, leaving me x squared and the minus 5. Notice that is the exact same factorization I had before, and I still get the same answers. Okay, now not every problem is factorable, so you can't always do this, but man, if you recognize it, go ahead and give it a try and see if it works out for you. If not, the worst thing you have to do is cross it off and just go to the next problem. Speaking of which, here's our next problem. Last one. Okay, let's make sure we understand. Describe end behavior. These are the ends out here where it's going up and going up off the paper. So we can see on both ends it goes up to infinity, and so we say this, on the right end, as x is on the right side, the function goes to up, infinity. And on the left side, as x goes towards the negative infinity, where did the function go? Well, it went up towards infinity. That's this one right here. And this one is that one. Okay, so there's our infinity stuff. Describe the x value, so here's our x-axis, right to there. Where the function, the y values are positive. Okay, so let's look where the y values are positive. Here's the x-axis. Positive y's are above it. Okay, so this little wing right here, this hump is above it, and over here it's above it. So we just have to describe the x's. So let's see here. This happens at negative 4. This is a 2. And this is a 6. So to the left of negative 4, I'm above it. So I'm going to write this, left of negative 4. So any x's there put me above it. Then I'm also above it between the 2 and the 6. So let's trap it between 2 and 6. And then also when I'm bigger than 6. That's this wing out here at the end. So those are the regions I'm above it. Where am I below it? Well, I'm below in this region, everything between negative 4 and 2. And that's it. It's the only time this thing's ever below, so only x's in that region ever give me negative y values. And then lastly, where does it equal 0 at? Well, that's right where it crosses the x-axis, our solution, so at negative 4, at 2, and at 6. At 6, you might want to put multiplicity 2, because that's what's going on there. It's just touching and pulling away. So there's 4 solutions shown, negative 4, 2, and 6 twice. And that's it.